Hey there, welcome back to another functional C# video in the Flow series. While we're working with Flow specifically, the principles in this episode apply to result types in general, regardless of the library or implementation. Today we're going to look at chaining and transforming Flow results using the other overloads of the OnSuccess and OnFailure extension methods. Under the hood, these use Flow's core map and bind methods, the fundamental tools of any monadic result type. Quick side note, if Flow's naming style doesn't match your domain language or project vocabulary, that's fine. Flow exposes map, bind and match directly, so you're free to wrap them in your own custom named extension methods that better reflect your intent. Before we dive in and before I forget, let's quickly talk about Flow's built-in failure types. What you see on screen is the source code for Flow's failure hierarchy. All built-in failures inherit from the abstract failure base class and therefore expose the shared properties defined there, including reason, subtype ID, details and optionally an inner exception. One important note, if you include an exception when constructing a failure, be aware that exceptions won't be serialized when using JSON or gRPC. That's by design. Flow intentionally discourages serializing exception objects. Flow includes a variety of predefined failure types, all marked with attributes to work seamlessly with system.text.json and code-first gRPC. The subtype ID property is useful if you want to subcategorize failures beyond the built-in types, but you're also free to create entirely custom failure types by inheriting from the failure base class. If you go the custom route and need them to be serialized, especially across gRPC or in a web API, there's a bit more setup involved due to the inheritance structure. For now, I recommend checking out the examples in the Flow repository, but I'll likely cover custom serialization in more detail in a future episode. Lastly, it's worth noting that when a flow is in a success state, its internal failure field is set to a special marker called no failure, essentially a sentinel object. Alright, that's the context you need on failures. So let's jump into today's topic, transforming and chaining Flow results. I won't get too deep into the functional programming terminology, but here's what you need to know. Under the hood, Flow relies on two key methods, map and bind. These allow us to reach into a flow and transform its internal value or even change its type. Map takes a function that transforms a value and wraps the result in a new flow. Bind takes a function that already returns a flow and flattens it into a single result, avoiding a flow of t situation. This flattening behavior is why bind is sometimes called flat map in other languages, because it reduces nested flows into a single chainable unit. But that's enough functional lingo for now. In practice, we just use the OnSuccess and OnFailure extension methods and the overloads that accept transformation functions. These let you chain operations that either return a simple value or return another flow depending on your needs. I'm keeping it simple today with just one example, because for many developers this kind of chaining and transformation can take a little while to fully click. But once it does, you'll realize how much complexity it removes from your code. So here's a scenario. A user wants to update a contact's profile so the view is up to date. Since I work with Blazor a lot, you can imagine this being triggered from a Blazor WebAssembly app that talks to a web API using commands and queries. But it could just easily be a desktop application sending data to an application facade. The request sends updated contact data to a controller method. That method passes a command to a command handler, which first validates the data. If the command is valid, it writes to the database. Since it's a command, we don't expect a return value, but the UI still needs an updated view, so we make a second call to retrieve the contact data and return that to the user. So what could go wrong? The contact data may fail validation. The record might have already been updated or deleted. The contact might be gone before we try to fetch the view. And that's with no serialization, no authorization, no command timeouts, no transitive failures, which in a real-world system are all on the table. So even in this simple case, you could end up writing a lot of boilerplate code. For this example, we simulate failures with randomness using the Core's random failure method, which lets us mimic real-world branching and failure paths. On line 25, we create a new contact object. Think of it like form data from a user. The loop runs the whole process a few times to showcase how different failure paths behave. On line 32, we call the main orchestration method SomeController update contact, passing in the contact data. This method sends an update contact command to a handler where it first gets validated, shown on line 44. The command validator on line 52 returns a flow of bool. If validation fails, we return a failure immediately. If it succeeds, we proceed with saving the data. Now here's the interesting part. Even though the validator returns flow of bool, the handler is supposed to return flow of none. But because bind via OnSuccess transform the flow as it chains, the failed flow of bool is automatically transformed into a failed flow of none. No extra logic needed. That's monadic magic. If the validation succeeds, we move on to saving the contact. That call may succeed or fail, but either way we wrap the result in a flow and move on. Back in the controller method, we check the result of the update. If it succeeds, we call another handler to retrieve the latest contact view. If it's failed, we stop right there and return the failure. The handlerGetContactView method on line 56 simulates that second data access, which can also fail. The result eventually bubbles back to line 32, where we use the finally extension to extract the result, handling both success and failure. The failure handler just calls show failure dialog, shown on line 61, which would realistically show a dialog to the user and/or log the failure. In this instance, the failure path then just outputs a null. The success branch unwraps the contact view. We then print out what was returned from the finally method if it wasn't null. It's a lot to follow the first time, so I recommend walking through the flow step by step until you see how each branch is handled dependent on success or failure. Alright, let's run the app and see how the random failures play out. Okay, we hit a couple of validation failures. Let's run it again and see if we can get at least 2 different failure types to occur. Since last time, I updated the program so you can just type an R to request that the current example is repeated. And there we go, 2 out of 3 possible failures showed up. But I think you get the point. Nothing crashed. Everything was handled gracefully. No tangled if-else blocks and no exceptions thrown just to be caught and rethrown. Now I know some of you are probably looking at this and thinking, okay, but this is just toy code. In a real app, we'll still have try-catch blocks and guard clauses everywhere. There's no way it could be this simple. Well, I respectfully disagree. In the next episode, we'll expand on this idea. Yes, still with simplified code, but this time we'll integrate exception handling into Flow. After that, we'll start layering in more realistic examples calling a server over Web API or gRPC, issuing commands and queries against a real database, and see whether Flow or any result type can help you write code that's easier to follow and maintain. Before I leave you with that thought, just a reminder, although I tend to write unbroken flow chains, you don't have to. You can stop mid-flow, do whatever you need and continue when it makes sense. It's entirely up to you how you structure your logic. As always, feel free to leave comments, good or bad, and I'll do my best to answer any questions that come up. If you found this video or source code helpful, please consider liking and subscribing. It really helps the channel grow. Thanks for watching. Until next time, bye for now.